Hi, Algebra 2, pre-AP. Make sure you listen to the right video. Or watching. Whatever you do with videos. You do you. Anyhow, let's get lesson 7 done. Let's talk about how these two equations here are related. Well, aren't they just exactly the same? Kind of a no-brainer, isn't it? And you can see that if I was to divide both sides by x plus 1, right? There it is, right? Just to do some simple algebra. And we find out that they are the same, right? They're the same. All right. What about the relationship between these polynomial identities, right? That x squared minus 1 equals x plus 1 times x minus 1, right? This is difference of squares, right? And this other difference of squares. Well, these are pretty much the same as well, right? Except for in this case, right? If we were to just go ahead and let a equal 1, then we get this one, right? So one is a general equation for our difference of squares, and the other is a specific equation for difference of squares when a is equal to 1. Sorry about that. Okay. Now, before we get into these exercises, I want to explain a little bit more. So I'm going to go ahead and add a page in. And I'm not sure where you might want to write this. Possibly on one of the pages that was intentionally left blank. Or if you want to put it in a separate notebook sheet page, that's okay. I'm not doing a long description, just kind of getting into the nuts and bolts of what we're doing here, right? So if we look at that equation that we have at x minus 1 times x plus 1, right? Again, it's difference of squares, so we can write it in this way, right? But what if x was equal to 100? Well, we have if x is equal to 100, right? So if I substitute 100 in, it looks like I am actually calculating, right? You see, this is 99 times 101, right? Which might be kind of difficult to do if you're going to do some mental math. There's a really easy way to do this problem using the idea of difference of squares. And what that works out to be is that isn't it the case that I could write this as a difference of squares? So couldn't I also write this as 100 squared minus 1 squared? Right? I'm saying that because it's difference of squares, I can write it in that way. And then it becomes much easier for us to do such a calculation, right? You could do that. I'm sure you've already done that in your head. Okay? So we have this general rule that we just talked about of our difference of squares. Right? So we're going to use our difference of squares identity to do a lot of these things, right? So and let's do another one, just really explicitly using this identity. So this identity right here, right? And you guys have seen it a bunch. So our difference of squares identity, right? And what happens if I keep x equal to, so we're going to keep x equal to 100. And now let's let a equal 5. So if that's the case, then I can write this. And more importantly, what is that? It's actually a way that I can calculate something that normally would have taken a little more time if I was to do that mentally. And what is that I'm calculating? It turns out to be 95 times 105. Might take you a little time to calculate that mentally, unless you recognize that that is the same thing as this 100 squared, right? 100 times 100, which is 10,000, right? Minus 25. Well, that's easy, right? No problem. That's 9,975. But if you were to do 95 times 105, it might take you a little bit longer. And if you were to use the trick of using difference of squares in order to do some mental math. All right? How are we using that? It has to be the case that that our A is the same. When A is the same, we can use this trick every single time. So now that that groundwork is laid, let's go ahead and try some problems. We can get back over here. All right. So we're going to compute these products using the identity. Well, that identity, right? Difference of squares. So, how are we supposed to do that? Well, if we notice, we look at this 6 and 8, right? We got to think, what number are 6 and 8 the same distance away from? 7 is correct. So I can write 6. Isn't it true that 6 is equal to 7 minus 1 and 8 is equal to 7 plus 1? So then can I say that 6 times 8 is the same thing as 7 minus 1 times 7 plus 1? Well, yes, I can. Yes, I can. Which we can then use that identity to say that that's the same thing as 7 squared minus 1 squared. Okay, what is that? That's 49 minus 1, or 48. And we got that right because we know our times tables. Let's do it again with something a little more challenging. 11. For all you New Mexicans. Times 19. Well, 11 and 19, what are they the same distance from? A number that 11 and 19 are the same distance from. All right, so 15. So then that means that I could say that 11 is the same thing as 15 minus 4. And I could say that 19 is the same thing as 15 plus 4. And then we can use our property. Which means that that is going to be equivalent to 15 squared minus 4 squared, which is the same thing as, what is 15 squared? It's 225 minus 16, which is 209. All right, and that's our previous circuit. Let's continue on. And we can do this again. All right. How do we figure this out? Another way to do it is take 23, subtract 17, and then cut that number in half, right? And then we'll figure out what number we're looking for. Namely, we're looking for 20, right? So I can express 23 as 20 plus 3, and then I can express 17 as 20 minus 3, which means that 23 times 17 is equal to 20 plus 3 times 20 minus 3, which is 20 squared minus 3 squared, which is equal to 400 minus 9, or 391. Let's do it again. And now you can see, actually, with the larger numbers, this is actually not a bad way to do it, right? All right, so what number is going to be directly in the center, right? Directly centered, if you're looking at it on a number line, between 34 and 26. That number is going to be 30. So I can say that 34 is equal to 30 plus 4. And I can say that 26 is equal to 30 minus 4. And that means that 34 times 26 is going to be equal to 30 plus 4 times 30 minus 4, which turns out to be 30 squared minus 4 squared, which is 900 minus 16, or 884. So there's a cool way of doing some mental math. All right, so we're going to skip this one, and we'll talk about this a lot more when we look at finding primes in lesson 8, which is coming up tomorrow. There are problems below, which we're looking for. Okay. But this is an interesting problem that I do want to work for you guys. So let's look at this. Let's show that 8 cubed minus 1 is divisible by 7. Remember that I told you about this property. Remember we said that if we have some x to the n minus some a to the n, and if we were to divide that by x minus a, x minus a, that's the same thing as a to the 0, x to the n, x to the n minus 1 plus a to the 1 times x to the n minus 2, right? And we keep doing that all the way up to a to the n minus 1 x to the 0, right? Well, we can rewrite that in another way, right? We can multiply both sides by x minus a, and we can get that this equivalent formula that says that we can express this as two factors. The one factor is simply x minus a, and the other factor is all of this other fun stuff over here, right? This expression. And I may have room, let's see. All right, not as neat as I would like it to be, but there it is. So I'm going to use actually this property to show that that 8 to the 3rd power minus 1 is divisible by 7. Can I write this? I can rewrite this as 8 to the third power minus 1 to the third power, can't I? I surely can. And I need a little more space, so I'm going to write it down here. So, let's write this right down here. 8 to the third minus 1 to the third, right? So now I'll look at that lower equation that we wrote and write this. So I can write this as, first of all, let's figure out what is x, right? In this case, right, x would be, oh, it's 8, right? And then what is a? A is 1. So then I can write this as 8 minus 1 times, and let's go through that, right? So 8 to the 0 power is 1, right? Anyway, so, and then our x to the n minus 1, so this is 8 to the second power, right? 3 minus 1 plus 8 to the first power, which is just going to be 1 anyways. And then we have our x to the n minus 2, which would be just 8 to the first power. And then we have our last term here, right? Which is going to be, right, this term right here. So what's a to the n minus 1? Well, n, remember, I didn't say it, but clearly n is 3, right? So we're talking about 1 to the second power, which is just 1. So what's this right here? That's 7, right? So then we can also express this as 7 times 8 squared plus 8 plus 1, which clearly shows then that that is divisible by 7. In other words, 7 is a factor of 8 cubed minus 1. Alright, so that's it for this lesson. We're really going to bring it home in the next lesson. During lesson 8, we're going to be able to find out if numbers are prime, and we're going to also just take this to a whole nother level. It's going to be great. Can't wait to be there with you. Thanks for watching. Have a great night. See you tomorrow.